Hello, my name is Martin. I work for Red Hat as Cloud Services Architect. Today we're going to talk about serverless application development using Quarkus, GraalVM, Knative, Glue, and Kubernetes. And these are the stack versions if you're interested. I'm running Kubernetes locally. It's a single cluster deployed using Minikube. And for today's flow for presentations and demo, at first we're going to install GlueCuttle. So what is GlueCuttle? GlueCuttle is Glue command line interface, which allows us to install Glue and Knative easily on top of Kubernetes. And then we're going to create a Java application using Quarkus framework, and we're going to convert that Java bytecode into a native image using GraalVM, and then we're going to bundle that native image inside Docker image, and then we're gonna push that Docker image into a Docker Hub, and lastly we're going to create Knative service definition file, which is in the form of YAML, to deploy our Docker image into Knative. Okay, so that's basically the flow of today's presentation and demo. So without further ado, let's go to install GlueCuttle. Before installing GlueCuttle, it is best to know what is Glue. Glue basically in high level is a Knative ingress controller, right? So for those of you who are not so familiar with ingress controller, so you can go to kubernetes.io documentations, but before understand the ingress controller, it's best to understand what is ingress first. So basically ingress in Kubernetes term is a set of routing rules, right, which dictates this particular traffic will be routed to which service on which port. So this is the example of ingress object within Kubernetes, and the ingress controller understand this, right? And then it act upon it as a proxy. All right. So there are few ingress controllers available here, as you can see. It could be F5 big IP controller. It could be Glue. Okay, we are going to use Glue in this case. It could be a HA proxy, Kong, Nginx, and so on and so forth. So if you are coming from OpenShift background, you can easily relate ingress controller to OpenShift router port, right, which is by default implementing HA proxy, right? So Glue also comes with API gateway powered by Envoy. That's why you get to see this rate limiting and caching, so on and so forth. Okay, so without further ado, let's install GlueCuttle. To install GlueCuttle is very straightforward. There are a few ways of doing it. So you can use package manager using Homebrew or Goldfish or whatever. As I am running Fedora Linux, I just need to execute this curl command line, right, into my terminal, which I have done it. So if you want to see it, I can spit out the versions. It's okay. So the version that I'm running right now is GlueCuttle version 0.13.20. Okay, so once Glue has been installed, you can continue to install Glue itself. Okay, there are two ways of installing Glue. One is actually using the command line, which we are going to do so, and it's according to this documentation, it is a recommended way. The second is via Helm, right? So in order to install Glue using GlueCuttle, which is the CLI, we have a few flavors here. So first is actually installing a full sets of glue which comes with API gateway, and the second is to install it as part of the Kubernetes ingress controller, and then the third is actually to install glue together with Knative so that they can integrate automatically. So for this presentation and demo, I am actually going to select this. So how about to do it is actually, if you scroll a bit, go down, and you find this part. Okay, so in order to do so, installing glue and Knative at the same time, you just need to install glue. You just need to run gluectl install Knative, and then once you execute that, it will create two new namespaces. One is knative-serving, and the other one is glue-system. So I've executed in my machine. So if I run kubectl get namespaces, you get to see, let me make it slightly bigger, you get to see the two namespaces mentioned, right, which is glue-system and then knative-serving. So if I want to know what are the pods get deployed into respective namespaces, I can run this command. Then I get to see under the glue system there are 4 pods, just this one, and then under the Knative is gonna be this pods. Okay, so I have glue and Knative up and running in my machine. So what's next? Next is actually to go to the next step, which is it is better for us, before we deploy anything, before we go into more deeper, let's get a better understanding of what Knative is. So according to this documentation, if you go to the knative.dev website, it says that it's Kubernetes based platform to build, deploy, and manage modern serverless workload. So in another word, it's basically is a serverless framework for Kubernetes. Knative has 3 different components, right? 3 different building blocks. Some people call it primitives, right? One is build, which is self-explanatory, is to build from the source code, and then build containers, and so forth. For this demo, I'm not gonna use this build because I am going to use Quarkus Maven build. And then the second one is eventing, right? Eventing is basically is a way of your serverless applications to receive event and act upon it. Eventing in Knative is still pretty new. They are still work in progress. In fact, if you go detail into it, you get to see that. Okay, let's go to the eventing. Some of the component for the sources are still proof of concept and active development. The same thing for the channels, right? So for the third one is serving, right? So the Knative serving. So we're going to drill more serving. So what is serving? Serving, if you go to the back to the Knative documentation and select serving component. So serving is actually consists of a few CRDs, few custom resource definitions. There is a service, there is a route, there's a configurations, there's a service. All right. So basically, in high level, what Knative serving is. Knative serving is actually a place for you to deploy your applications, right? Your serverless applications, and then upon receiving the Knative's service definition file, Knative will then create configuration and route. All right, and then after creating a configuration will then take a snapshot of your code and then create a revisions. All right, and then the route, from the name implies, will route the traffic to the revisions, right? So basically, in high level, service will holds of these objects, right? So it's also handle auto scaling feature, all right? So it allows you to scale down to zero, scale down your serverless application to zero if no traffic at all, and then scale out accordingly if there's a lot of traffic coming in. The scale in, scale out as well. It is if you can easily relate to horizontal port auto scaling, it is pretty much I would say almost the same concept, right? But just in this case, for service, it allows you to for Knative service, it allows you to scale down to zero, right? If there's no traffic coming in, and Knative by default is using traffic. If let's say if there's a traffic, there's a request coming to this the serverless applications, it will then if there's no port available, it will spins out one, and if there's more traffic coming in, it will scale out, right? So it's scale in it's scale out based on traffic. For horizontal auto scaling, we by default we have a few options. So we have CPU based auto scaling. So if let's say we detect the CPU spike to 70%, so we can scale the port to for example to 3 or 2, right? So but in Knative it is based on the traffic. You can also, however, to configure Knative to also scale out the serverless applications based on the CPU consumptions, right? There's a way to do so, but that's not the that is not what we're going to cover in this demonstrations. So that's basically Knative service, and then once we stand up Knative and Glue on top of our Kubernetes, we can proceed with the third flow, which is creating applications using Quarkus, right? Java application using Quarkus framework. So in order to do so, you can go to quarkus.io, but I'm not gonna talk about it now, because I have created a video last time, which is this one, which is a demo or getting started with Quarkus, right? You can watch this video to get a better understanding what is Quarkus, what values it brings to the table. I will attach the URL inside the video descriptions, right, so that you can watch it yourself later on. I have stand up a Java applications. All right, so this is my Java applications. So in my Java application, I expose 3 different resources, which is basically is REST endpoint. First is actually /hello, and then the third one is /hello/grid, which is what it does is actually it tried to load value from property files or load value from environment variables using this message key. So the value, I have put it inside my application.properties. The value is days of serverless application development. Okay, so there's the second REST endpoint. The third REST endpoint is /hello/quote, and then basically what it does, it will call the quote of the day bin. Okay, so I am basically demonstrating to you that dependency injections, or CDI, content dependency injections, is supported by Quarkus. You get to see by seeing this at application scope annotations, and then how you consume it. You just need to inject it, right? using @inject, and then just call the method accordingly. So basically what it does is to load you know, code based on its index. Okay, so this is my applications. It has been running properly, and I can show you here. If I were to run my applications, I can do a Maven, or since I have okay, so I can do Maven compile Quarkus equivalent to dev. This is going to activate the hot deployment feature, and I'm sorry, I have some, okay, so let's do it again. So I am trying to activate the hot deployment of Quarkus in this case. It is up and running in 1.384 second, running on port 8080. So if I were to curl it, okay, localhost port 8080/hello first. Oops. So it spits out hello as expected, because it will entertain by this method. And if I try to access a different endpoint, it will spits out this taste of serverless application development. And then if I were to access another endpoint, which is the quote, yeah, using the index, for example, the first index, you get to see this second index, right, which is coming from this array of string. Okay, this is number one and this is second, right? So it is fully up and running. Once we have these applications, we can actually start converting these into a native image. So let's go back to the Quarkus IO documentations, and then we going to select this tutorial or documentation says that building native image guide. In order to create a native image, you need to install GraalVM first. Okay, so if you haven't done so, you can actually go and grab it from GraalVM website, and then if you want to know more about GraalVM, you can look for their website here, and once you download, you need to install, and you can just follow this documentation accordingly, right? So I have GraalVM installed on my machine. So next, based on our flow, is to convert the Quarkus Java applications into native image. Okay, so in order to do so, you can run Maven command, which is Maven package pnative, which it will activate the native profile here. All right, and then what it does, it will execute this Go native image, which is eventually called GraalVM native image tools to convert bytecode into binary, right, into native binary. And I have done it since it takes some time, like 2 minutes, something less than 3 minutes. I have done it in my previous step. So I've done it, so it does tells me that it requires about 2 minutes 42 seconds to complete, right? So to save time, I've done it as well. The next, after we create the native image, we need to bundle it, right, using Docker in this case.
So I've also run this command. Okay, so if you look at this producing a container instructions, in order for you to kind of prepare the Docker image build for the native image, you can just invoke this package pnative and then dash native dash image dot docker dot build equal to true, and then once you are finished, you can finally invoke this, okay, docker dash build. So basically you are building a Docker image, and then it will using this Docker file, okay, that is docker file dot native under slash src slash main slash docker. So if you need to see from my editor, so it's here, okay, so it's here. So you can read what is inside, and then after that you can tag it with a specific tag, okay. So I have already done it in my environment. So I am this one, so I'm tagging it with tag Quarkus slash Quarkus dash knative dash inf demo. All right, so that's it. Okay, so I've run it. So what that instruction will do, it will create a Docker image with this tag. Okay, so let's see. Okay, so I'm going to call my Docker images, and I'm sorry, I can do a sudo Docker images. Oh, typo. So I have one here. Okay, let me make it bigger, a bit easier to see. Okay, so I have one image which is tagged the same with what I have created before using Docker build. Okay, so it's basically this one, Quarkus dash Quarkus knative demo, and here you go, which is created about 3 hours ago. Okay, so what's next? We need to push this into our Docker Hub. Okay, so you need to log in to Docker Hub using your credential, and then you need to create a repository and then push it to your repository. Okay, so in order to do so, you can run a command something like this, docker tag, and then this is the Docker that we have built locally, which is in the latest versions, and then you can use this new tag, right, docker io slash, and then followed by your username, for example, whatever. All right, and then your new repo, right, your repository, and then you can tag it using, for example, maybe latest or v1 v2, whatever you can call it, right. So I'm using latest in this case. So you can just tag your newly created Docker using this one, and then once finished, you can do a Docker push. Okay, Docker push to this URL. Okay, so once you execute that, it will push this Docker image into your Docker IO public registry. Okay, so I've done it, so I'll show you here. I've pushed it to my Martin slash Quarkus dash knative dash demo. Okay, here. All right, so it is available now. Okay, so it is updated about a few moments ago, and what we need to do next is once we have pushed the Docker image into the Docker Hub public registry, the last part of our flow is to deploy it, right? Which is to excuse me, which is to create a Knative service definition file, which is none other but the YAML file in this case, in our context, and ask Knative to deploy that Docker image. So I have okay, let me go back to another terminal. So I have another I have a service that I have created before, which is as you can see here, okay, the service.yaml, and the service API is tagged with this serving.knative.dev/version1 alpha1, and then it is kind of service, which is Knative service, and then it is has a Quarkus Knative demo as a name, and then I'm going to deploy it inside the namespace, default namespace, and then the next thing is I'm going to instruct Knative to download my image, which is Quarkus -native -demo latest under this URL. Okay, so that's about it. So let's go and deploy it. But before we deploy it, let us use these two terminal to do something interesting. So I'm going to, at this terminal, I'm going to execute this command, kubectl get events, to kind of listen to what events or logs has been happening, all right, or has been thrown if we invoke something on a specific namespaces. So I'm interested in namespace default, where I deploy my serverless applications, and then I'm going to sort it first so that it is sorted by timestamp. All right, and then I'm going to watch it. Okay, so as of now there's no event at all, so leave it like that. Okay, on the other terminal, which is the bottom right corner here, I'm going to execute watch to actually pull out frequently the pods that inside the default namespace. Okay, so what it does is basically it will list out the pods. What are the pods that been deployed into this default namespaces. Okay, we are good. So next we're going to we have the service already here, so we are going to execute that. Okay, we're going to apply it into the Kubernetes, and then see what happened. Okay, now there is an event going on in default namespace, and you can see that it is downloading my image, Docker image from the Docker Hub, and it is running now. Cool. So we have our first serverless application up and running inside the default namespace. So what's next is actually how to access the application. So in order to do so, you need two things. One is actually you need to have, if you look at the Glue architecture looks like, the Glue is actually fronting the underlying services, right, from the external users or external traffic. So in this case, we need to find out where is the URL that actually where the proxy URL of Glue itself. So in order to do so, you can use a kubectl Okay, so before that, let me show you a couple of interesting facts. If you run a kubectl get service, all right, under glue dash system, you get to see there's a service called ingress proxy, and if you get ports, you get to see there's a cluster ingress dash proxy port associated with it. Okay, so this is the service, the proxy service that we need to actually get the URL, the external URL, so that we can access our service, right, our serverless application. So in order to do so, you can do this kubectl proxy URL and then dash dash name. You give it the name of the service here, which is cluster ingress dash proxy. Okay, it will spit out this URL. So this is the external URL that you can invoke from outside Kubernetes. Okay, in order to make things easier in for our subsequent demo, I'm going to export it. I'm going to export this ingress proxy into a variable, so that we don't have to copy and paste the URL or to remember the URL ourselves. So let's do that. So let me test it first. Okay, kubectl. Yep. Okay. So so once we know the ingress proxy control URL, what you need to do is actually to get the route. Remember, where is it? So if you go to the back to the Knative documentation again, if you go to the serving component, and you get to see this route. Okay, so this route is actually is responsible of routing traffic to your configurations, to your efficient. Sorry. Okay, so in order to do so, we can invoke kubectl get route. If you notice that it is actually similar to these CRDs, right? This CRD, okay, custom resource definitions, which is created by Knative. Okay, so we do that, and okay, so we have this Cortex Knative default example.com domain. So now how are we going to access our application or our serverless application? We can do this curl. We put this domain as part of the host HTTP header. We can do this. We can, and then copy this one. As I'm explaining, the service is terminated. This is where the scale to 0 feature in Knative, right? Serving. So it is going to kill the pod, but doesn't matter. We can always instantiate it later by sending traffic to our serverless applications. So so we're going to access it now. So you're going to copy this one and paste it here, and then after that we're going to use this URL, which is the ingress proxy URL of Glue, and then we going to access what functions that we going to invoke. So as I told you, we have three different REST endpoint. There's a /hello, /grid, and /quote. So in this case, let's try to invoke the /hello first. Okay, now based on this, you can see this the pod gets instantiated after we call our /hello. Okay, this is the auto scaling feature of Knative serving. So let's try, I'm sorry, grid endpoint. Okay, cool. So let's try quote, and going to access the index 1 and access index number 2. Cool, it works. All right, so this is how you deploy your application on Glue and Kubernetes and Knative on top of Kubernetes, and then how you access it after that. Okay. Next, we're going to play around with our service a little bit. So assuming that we have our first service, which is this one, and assuming there is a new revisions, let's say we're going to modify the service a bit. Let's say now I am going to tell Knative service to disable, or to, to disable the auto scale to 0 feature, by saying that Knative, please maintain at least one port for my functions, right? So of my serverless applications. So in order to do so, you can use this using this annotation, which is autoscaling.knative.dev/minimum scale to 1. And then we can also say that I also need to make sure that it can scale out very well, entertained by 4 target ports. And then next, let's say I am going to modify the message. Okay, so basically this one, okay, load from property. So I'm going to modify this, which is original value is taste of serverless application development. I am going to change it to something more fun. Let's say I'm going to call it version 2.0, right? Then once I'm happy with it, I can just run it. Okay, then you guys see this 2 window. It will do something interesting. So once I'm ready, I can just apply it using kubectl apply again. Okay, so all right, now the new version has been deployed. Okay, it's just stood up about 6 or 8 seconds ago. Cool. So let's test it out. So let's invoke our endpoint again, and we're going to see whether the grid, okay, /grid, right? Yeah, whether the /grid has been changed. So initial value is taste of serverless application development, and we have changed it to version 2.0. So let's see, is it changed? Yes, cool. So it's changed to version 2.0 already. So then what's next is actually we're going to see the scale out feature of Knative serving capability. So with that, I am going to send a traffic. I am using Hey in this case. So I'm literally saying that I'm going to execute it for 60 seconds using the -z, and then I'm going to use 1000 concurrent connections. All right, and I'm going to use it now. Okay, so this is the host, which is basically it's the same thing. Okay, this one. So with that, before I invoke this, you guys go and take a look at this port list of the port under this default namespaces. Okay, I'm going to send 1000 concurrent connections for the next 1 minute. say see what is happening. Okay, so I'm executing it now. So it's sending a traffic to, okay, now as you can see, the auto scaling feature kicks off. It's scaling out the pods. It's creating more pods to serve the traffic, which is good. It is very useful if, let's say, you have suddenly tons of traffics coming in, and yeah, I'm sorry about that, I have running off CPU. Yeah, my machine is gonna blow up, but at least you can see that the auto scaling feature of Knative serving is kicking off right now, and is alive now. So with that, I'm going to end my presentation and demo. Hope it's useful. Let me know if you have any questions, and yeah, thank you so much. Thanks for watching. Bye bye.